Welcome, developers. Let's get started. Today, we're tackling a common team pain point, terrible Git commit messages. We will learn how to use context engineering within Claude Code to automatically generate highly descriptive, standard-compliant commit logs, saving you time while keeping your repository history pristine. Let's define what we mean by AI-assisted Git commits. What is it? It's using Claude to automatically review your code modifications and write the log for you. The basics are simple. Claude looks at your files and summarizes the changes. Why is this so crucial? Because we all know developers rush commit messages at the end of a long day. Messages like "fix stuff" ruin your Git history. How do we fix this? By asking Claude to handle the commit via the CLI. However, in our deep dive, we must realize a core limitation. A naive prompt will just yield a literal summary of code changes, missing the why. To get high-quality logs that capture business logic, we must engineer the context. Look at this flowchart representing a naive AI commit workflow. The developer changes the code and asks the CLI to commit. Claude reads the Git diff, generates a literal summary like "changed const x to let y," and produces a suboptimal commit message. It works, but it lacks the necessary business context to be truly useful to your team. To fix generic commits, we must learn context engineering. What is it? It's the process of designing the environment and data an AI relies on. The basics contrast it with prompt engineering. Prompting is like asking a consultant a question, while context engineering is like onboarding an employee with tools, rules, and live data. When do you use it? Whenever you need the AI to understand real-time system state. Why does this matter for commits? Because without knowing your current branch name, your recent commit history, or your team styling rules, the AI operates in the dark. How do we solve this? We build a custom Claude Code skill that forcefully injects this exact context into the prompt before the AI even reads it. This diagram illustrates the pillars of context engineering. Instead of just passing a text prompt, we provide environment rules, live data representing system state, and specific tool constraints. When all three of these context streams merge into the AI's processing engine, they produce the green node at the bottom, highly accurate, high-quality AI output that actually aligns with your team's expectations. To standardize our commit process, we package it into a Claude Code skill. What is a skill? It's a reusable markdown file that encapsulates a specific workflow. The basics involve creating a skill.md file inside the .claude/skills/ directory of your project. Why use a skill instead of just typing a prompt? Because it guarantees that every developer on your team will generate commits using the exact same optimized logic. How is it built? You start with YAML formatter to define the skill's name and description. In our deep dive, we learn about progressive disclosure. Claude constantly reads the description field in the background. When you type "push my changes," Claude matches your intent to that description and dynamically loads the rest of the skill into its memory, keeping the context window perfectly optimized. Here is the lifecycle of a skill invocation. The developer simply types "commit changes." Claude immediately enters an intent matching phase, scanning the YAML formatter of available skills. It finds a match, loads the full commit code skill.md file into active memory, injects your team's specific workflow rules, and executes a perfectly standardized commit. Now we reach the core of context engineering, dynamic context injection. What is it? It's the ability to run shell commands and embed their live output directly into the prompt. The basics: in your skill.md, any command prefixed with an exclamation mark, like git status, is executed locally. Why is this revolutionary? Because to write a good commit, the AI must see the exact code differences. How do you do it? Look at our sample code. By writing git diff head, Claude Code secretly runs that command in your terminal and replaces the tag with the actual code diff before the AI model ever reads the prompt. In our deep dive, we recognize this as a form of retrieval-augmented generation. We are retrieving the live Git state and feeding it to the AI, completely eliminating hallucinations. This sequence diagram maps the dynamic injection perfectly. When the skill triggers, the Claude Code CLI talks directly to your local terminal, executing the git diff command. The shell returns the raw diff text. The CLI then replaces the exclamation mark syntax with that massive text block, constructing a fully hydrated prompt. Only then is it sent to the Claude model, guaranteeing a highly accurate response. Once the AI has the context, we must enforce formatting using few-shot examples. What is this? It means providing the AI with concrete examples of what a perfect response looks like. The basics: we want our logs to use conventional commits, like feat, auth, Add JWT login. Why is this necessary? Because if you just ask an AI to summarize a diff, it will write a verbose, multi-paragraph essay that ruins your Git history. How do we fix it? We create an examples section in our skill.md. For our deep dive, we know that LLMs are ultimate pattern matching engines. By providing 3 diverse examples, a bug fix, a new feature, and a refactor that AI locks onto the semantic pattern, it will strictly conform to your layout, which ensures your auto-generated logs won't break your CI/CD changelog automation. Observe this state diagram outlining few-shot formatting. The raw diff input enters the pattern matching state block. Here, the AI compares the new code against the provided examples, a feature, a fix, and a refactor. By internalizing these structures, it safely transitions into the conventional commit format state, guaranteeing a perfectly structured output every single time. A critical aspect of agentic workflows is tool restriction for safety. What does this mean? It means actively limiting which tools the AI can use during execution. The basics involve defining an allowed tools array in your YAML front matter. Why is this mandatory? For security and scope control. You want Claude to commit code, but you absolutely do not want it hallucinating a command that force pushes to the main branch or deletes a database. How do we restrict it? We explicitly declare safe bash commands, like bash, git commit. In our deep dive, this is the application of the principle of least privilege. By strictly whitelisting the 9 Git tools, you create an unbreakable sandbox. Even if the AI gets confused or the context is poisoned, it is fundamentally blocked from performing unauthorized actions on your machine. Look at this tool security gate. When the AI proposes an action, it hits the allowed tools check. Benign commands like git status or git add are routed down the green path to execute safely. However, if it proposes a dangerous command like deleting files or force pushing, it hits the red node and is instantly blocked by the sandbox. Safety is guaranteed at the protocol level. Let's see this in a real-time, highly practical use case, the Git pushing skill. The scenario: a developer finishes a massive authentication refactor touching 15 files. They are tired and about to write a terrible commit message. Instead, they type /commit code custom JWT logic into the CLI. The execution begins. Claude selects the skill. The dynamic syntax pulls the massive Git diff head directly into the prompt. The AI reads the actual business logic changes. Guided by our strict formatting examples, it generates a beautiful, standardized message, refactor, auth, migrate to JWT tokens, complete with bulleted details. The value here is massive. The developer saves minutes of tedious documentation, team standards are flawlessly enforced, and your repository gains a professional, easily searchable Git history. This journey map tracks the seamless experience of our custom skill. In the developer section, they finish the code and trigger the command. Instantly, the context engine takes over, pulling the live Git diff and injecting the formatting rules. Finally, in AI execution, Claude analyzes the deep business logic, generates a perfect log, and safely executes the commit command on your behalf. Let's summarize our best practices for auto-generating commit messages. First, context is king. Always use dynamic injection like git diff so the AI operates on absolute facts. Second, restrict your tools. Explicitly whitelist safe Git commands to adhere to the principle of least privilege and prevent accidents. Third, provide examples. Few-shot prompting is mandatory to guarantee your output formats perfectly for CI/CD pipelines. Lastly, use the $arguments variable in your skills so developers can pass custom hints to guide the AI's focus. By combining dynamic context, safety constraints, and formatting rules, you turn Claude into a flawless code historian. I invite all learners to subscribe, and visit quicktechie.com for premium certification prep, including massive Q&A banks, full ebooks, audiobooks, full-length training courses, and expert interview guides. See you in the next module. Our final mind map synthesizes everything you need for commit mastery. From the center, we branch into context, highlighting dynamic injection. We branch into safety, emphasizing allowed tools and least privilege. We branch into format, relying on few-shot examples for conventional commits. And finally, flexibility, ensuring developers can still guide the AI using custom argument hints. Master these 4 pillars, and your repository history will be perfect.